Alright, so we're going to review the use of Newton's method to approximate solutions to equations. So we've got three examples we're going to do here. Probably going to take my time with the first two and then blaze through the third one pretty quickly just to make sure the video doesn't get too long. So you're going to want to use Desmos because we don't have the graphing calculators, obviously. And remember, we had a lot of cool tools and tricks that we were using with the graphing calculators. All of those work the same with Desmos. So maybe in one of our after-school help sessions, or today even, we could talk about how to use Desmos to make this quicker for you, because it's likely that on the test you'll be able to use Desmos and you'll want a fast way to do it. So in example 6, just continuing the numbers from yesterday, we have cosine of 3x equals 3x, and we're asked to find the solution using Newton's method to 6 decimal places. So when we find solutions, what we want to do is figure out when it is that this whole equation is equal to 0 by moving the 3x to the other side. So let's say that f of x is cosine of 3x minus 3x, because now if I've moved this 3x to this side and I call this all one function, all I'm finding are roots, and we can use Newton's method to find those roots. So if that's the case, remember in Newton's method we're going to need to use the derivative of your function as well, because Newton's method requires both of those things. So the derivative of cosine is negative sine, and there's a chain rule there. So the derivative of f of x is going to be negative 3 sine of 3x minus 3. So we've got our f of x function, we've got our f prime of x function, and now let's recall Newton's method. This is the little formula that we end up using, which just says that x of n plus 1 is equal to x of n minus f of n over f prime of n. Okay, so let's do this one time then. If I want to find the correct root, then I have to start somewhere. So where I'm going to start is at 0. Alright, and I'm just going to pause this and show you a graph of this function on Desmos and explain why it is I'm choosing to start at 0. So this is a graph of the function that we've just created, and so by graphing it, I know that I could just click on this thing, right? I could just click there, Desmos will tell me the answer, but I need to show that I can get there using Newton's method. So I'm approximating which integer is closest to that actual root, and it looks like 0 is pretty close. So I'm just going to start by approximating at 0, and eventually that'll get me closer and closer to the actual root if I continue using Newton's method. So now I can get rid of this. All right. So now my second x value is going to be based on that first x value. Right? So what is x of 1 minus, now I need f of x of 1 and f prime of x of 1. And this is where I'm going to do my calculations here. And so it's going to be 0 minus whatever f of 0 is. Well, f of 0, if I come up here and take a look at this function, 3 times 0 is 0. Cosine of 0 is 1, and so it would be 1 minus 0. All right, so 1 over, and over here, 3 times 0 is 0. Sine of 0 would be 0, and negative 3 times that would be 0, and 0 minus 3 would be negative 3. So I end up with 1/3, or approximately 0.3333, repeating, and I'm just going to show 6 decimal places because that's eventually what I'm trying to get to, right? All right, we need to do this another time. So the third term is going to be the second term minus f of the second term divided by f prime of the second term. And remember, this is the second term. So I'm just going to use green here and just explain where this needs to go. That needs to go here and here. So we need f of that, and here. So we need f prime of that as well. And I'm going to use Desmos. I'll do my calculation that way. and I'll get 0.2501, 2, and 1. Okay, so far, because these are not the same to 6 decimal places, I'm going to keep going. I'm going to write out the whole process one more time, and then I'm just going to show the solutions as you would continue this. And hopefully you pause and you've done this on your own, and you're just checking right now. So I need the third term minus f of the third term divided by f prime of the third term. And so that means that this whole thing, this 0.250121, has to go there, there, and there. And when I evaluate that, I get 0.246371. 0.246371. Okay. One more time, because these are not the same. So I'm going to calculate the fifth term. That's going to be the fourth term minus f of the fourth term divided by f prime of the fourth term. And this time, you should get 0.24662. And we are getting pretty close because 4 of those decimal places are the same. After you do it the 6th time, you will also get 0.246362, and so then you can be confident, because these are the same, that the solution to this original equation is that x equals 0.2466362 using Newton's method. All right, the next two I'm just going to go through quickly. I'll set them up and then I'll just show the solutions that we'll get from them. All right, so I'm just going to write Newton's formula down here so that we don't forget it. In order to actually use Newton's method, we have to have an f of x, which is this function. So x to the fifth minus 2x to the third plus x minus 4. We also have to have an f prime of x. This is an easy function to take the derivative of. 5x to the fourth minus 6x squared plus 1. All right, now we can start applying Newton's method. I'm going to start here with my first guess being at 2. And if you use 2 for your first guess and you throw it into this equation, then your second guess is going to be 1.754386. And if we continue using that as our second guess, throw it into the formula, our third guess should be 1.634830. And I'm going to continue. You should be done with this, because at your fifth guess, you'll get the same 1.605719 as you will with your sixth guess. So that's just to check your work. And so that will end up being your root. That is, so therefore the root of f of x is 1.605719 to 6 decimal places. All right, there's one more, and I'm going to get you started on it, and then I'll get you so you see the solution on the next page. All right, in this case, it's sort of like the first one where you've got an equation. So you want to take these terms and move them to this side first so that you actually have a function. So I'm going to say that my f of x is x to the fifth, but when I move that negative x to the third to the left side, I'm adding x to the third, so it's going to be minus 1x to the third minus x squared minus 5. And so when I take the derivative of that function, I get 5x to the fourth minus 3x squared minus 2x. And so when we use Newton's formula to approximate the root of this function here to 6 decimal places, we're going to want to remember that it's x sub n minus f of that divided by f prime of that. And so we can use a number of guesses. Again, this one, guessing 2 for your first guess wouldn't be a bad guess. And if you take it from there, you will eventually find on your 5th or your 6th guess that 1.649406 is the root. 1.649406 is a root of f of x. All right, so that's the solutions to the practice on Newton's method. And again, today we have after-school help from 3 to 4, so be sure to call in during that time and join the Zoom to talk about this or what we did yesterday if you've got questions. And tomorrow we're going to go over antiderivatives.